Okay, great. We can start the session now. Thank you for coming to this session. This session is about the query optimizer in SQL Server, about internals. I'm gonna show some undocumented traits, flags, features, statements to see the internals of the query optimizer. So, in most of the conversation is gonna be on undocumented features. So, and every time we say undocumented, it means you need to use that carefully. Of course, not in production environments, right? So you can use this information in your own instance, in your own laptop to see how the optimizer works. And by learning how it works, you can have better performance on your queries. You can write better queries. You can troubleshoot queries, okay? So my name is Benjamin Nevares. It's actually my first time. Really excited to be here in SQL Beats, the first time, and also in the UK. I've been working in 2 or 3 books. Recently, the one with Kalen Delaney, SQL Server, 2012 internals. I wrote a couple of chapters. I have a new book that is about to be published very soon about query tuning and optimization for SQL Server 2014. Okay, so let's talk about the query optimizer. What is the job of the optimizer? We usually submit a query to SQL Server, something like this, right? And we get an execution plan. And the reason is, for a specific query, there are many different ways to get the data, right? We call those different ways, we call execution plans. So basically, for a query, simple query, it could be many possible execution plans. And we need a component, the optimizer, to choose a good plan. Because if we don't have a good execution plan, well, what's going to happen? The performance, right? It's all about the performance. So that's the job of the optimizer on a brief overview. Also a reminder, this is a 500 level session, so it's a little bit advanced. So being that the case, you must be a little bit familiar with something like this, the different steps of a query optimization or query processing. So we have different steps: parsing, binding, query optimization, query execution. We're going to be looking at those a little bit. This is the same information, a little bit more detail, right? There is also a simplification phase, a trivial plan. So the optimization process in SQL Server goes through these different steps. It doesn't have to do all of them, but that's the basic idea. So let's start from the beginning. We submit a query, right? And actually, the optimizer is not going to work with the query. It's going to be working with something like this, the representation, like a tree, right? So the optimizer all the time is working with something like a tree. And actually, when you see an execution plan, it also has the shape, right? Like a tree of physical operators. And this is something that it is created at the beginning. So let's talk about the first 2 steps of query processing. Parsing, like any other computer programming language, there is some parsing that's going to validate the syntax and something like that. The next operation is binding, which is basically name resolution. It's going to relate, if we mention a stored procedure or a table, it's going to check that they really exist, right, on the database. After this process, the query processor is going to create a tree. something like this, tree of relational operators. So I'm going to show how the, and actually that's the next demo. There are some undocumented trace flags, and you can see these trees. They may look really complicated at the beginning, but you can see that information. So let me go into the first demo. And I have 5 demos on this session. For each one, there's information at the top about what I show on each demo. So, and I'm going to publish this. I don't know if there is a place on SQLBits to publish the demos, but I'll publish the demos and the PowerPoint. We are also going to be using this command a lot. This is a very well-known trace flag to display information about something on Management Studio. So some of these commands are going to be using also that trace flag to show information on the screen. So I need to run that first. Although much of the information about internals of the optimizer is not really available in SQL Server, we have a query like this, for example. This is a query that shows all the different trees that the query optimizer is using. So there is one original tree, and then there are changes that I'm going to be showing on the process. And for some reason, this DMB shows that information. OK. So I'm going to show something simple about how to use these trace flags. OK. We're going to be using something like this, query trace on, and then I'm going to specify the trace flag we are looking at. Right? You may be familiar with query trace on. It used to be undocumented. Recently, it's now documented and published by Microsoft. So you can use query trace on, but with some limitations. Only some specific trace flags are published and documented. And just a reminder, almost everything I'm going to show today is undocumented. So OK, so let me try that one. And basically, we can see information about the trees on the Messages tab. So, and you can take a look at this information. There are some operators. Logical operators, project, select, and get. I know it's a little bit, looks a little bit complicated in text, and it doesn't show like a real tree, but you can see that information, right? And just a reminder, this is relational algebra operations. So basically, it's even more confusing that does this select, it is not really, this select is really a filter, right? So the project operation is really list the columns. It has the columns over here. And select is really a filter operation. And get is the operation to get data from the table using an index table or something like that. So you can play with the other choices I have on the demo. But basically, the idea is that you can take a look at that information. Okay. Now let's go to something more, something a little bit more interesting, and that you can see, and also you can benefit of this. You can get better performance when you when you understand how this works, simplification, right? So, so far we have a logical tree of operations, right? The next thing the optimizer is going to be doing is going to simplify that initial logical tree, okay? So it may remove some operations or do changes to do the optimization process better and even to improve the performance of the query. So we have some operations like the optimizer may be able to eliminate some joins. I'm going to show that on the next demo. One example of that is foreign key join eliminations. It can also move filters at the beginning of the query. You know, in query optimization, we want to eliminate rows as early as possible, right? When we are reading data, if we can filter much rows as possible, all of that is better for the performance. So the optimizer is always trying to do that with many different optimizations. If there are contradictions, it may be able to remove some of those. And I'm going to show you that in the next demo. So I'm going to run this query and show the execution plan. You may have seen queries like these when, like in this case, I'm using 3 tables, but if you look at the plan, there's only 2, right? So that's an optimization that the optimizer is doing during the simplification phase. So basically here, if you don't have to access one of the tables, you are helping the performance, right? So what is the reason for this? This happened only with some specific conditions, right? In this case, we have a foreign key definition, right, with one of the tables. What is the purpose of a join? Yeah, 2 tables, match records, something like that. A foreign key has a similar purpose, right? So the optimizer knows, oh, there is a foreign key, and it's asking me to join 2 or 3 tables. So I know, because the foreign key is active, I know there is a match in records from one table to the other. So basically, the optimizer is using this constraint to help on the performance, because they have similar purposes: the foreign key and joining data from the table. Now you can disable that. I'm gonna do that here. So I'm gonna disable the foreign key constraint, and if I clean the cache, and I run the query again. So now the optimizer, it doesn't have that information. Let me show you here. So I disabled the constraint, so now the optimizer has no other choice but to scan the other table or to access the other table, right? Because it has to match records from one table to another, okay? So this is an optimization. You see here the benefit of using foreign keys to help on the performance of your queries. And it's like everything, right? Sometimes I present this on some other sessions, and some people try to, oh, I'm going to do that all the time. No, it's like indexes. Indexes are good but you need to create the right indexes and not that many, right? So you need to keep that in mind, that when a feature looks useful, you need to still use it with limitations. Okay. I'm going to enable back the foreign key definition, and obviously, if I run this again, I'm going to have only 2 tables. And we can use one of the trace flags we showed before to see on the logical tree when it is removing this, right? So there is a point here that we have 3 get one table, get the other table, get the other table, and suddenly we have this this part of the optimization, join, collapse tree, and suddenly we have only 2 tables. So I was able to remove the first one. Let me try some other. This is contradiction detection. So this is some of the other simplifications. I'm going to try this one here. This is also based on constraints. What do you think this constraint is doing? There is a check constraint to validate that vacation hours are between -40 and 240, right? So the constraint is already there on the database. What's going to happen if I run this query? Vacation hours greater than 80. It's going to access the table, right, to get me the data. I mean, there's nothing special right there. What do you think is going to happen if I run this? Vacation hours greater than 300. I mean, there is no data, right? We know that there is no data because we have a check constraint. But something interesting, too, is that the optimizer knows that and is doing nothing. It doesn't even go to the table, right? So the optimizer knows about the constraint and is returning something like empty, like this operator that is doing nothing, right? So the optimizer knows there's no data with that filter. We can also disable the constraint just to validate. Here, I'm going to disable the check constraint, and I'm going to run the same query. Am I going to get data? There's no data, right? But what's different now? The optimizer is not able to use the constraint, and it has to scan the table just to realize that there's no data, okay? Because the constraint is being disabled. So let me enable back the constraint. What do you think the optimizer is going to do in this case? There's also a contradiction right there, right? Manager ID greater than 10 and less than 5. So there's no way that you can get data, and the optimizer also knows that, and is doing nothing. It doesn't have to go to the employee table or do anything else. Okay, so Well, you might be thinking, nobody's going to write a query like that, right? Well, this is a very simple demo. In your production queries, your queries are more complicated than this. And sometimes you have one filter in one query and the other filter on a view that you don't even see on the same screen. So if you have a manager ID greater than 10 and then using a view, and manager ID less than 5 is on the view, this also works. Okay? And I think that I was using the trace flag to show how a complicated tree suddenly became nothing. I mean, this is the same operator I show on the execution plan. Okay, so let's continue with the job of the optimizer. We just started from the very basics. 2 steps we show already. The first one is when the query processor is building a tree of logical operators. We also show the simplification, right? That we have a logical tree and the optimizer can simplify the tree by removing operations or changing some operations. But this is really the beginning of the optimization process, right? The query optimizer uses rules, transformation rules, to create choices, to create additional choices. Because remember, at this point, we only have one tree, right? And what is the job of the optimizer? It's looking for different choices, different possible plans. So basically, it's going to use rules to find additional operations or plans, okay? Now, to explain that in a very simple way, let's suppose that this is the original tree that we have. If we apply a rule, we can have a similar tree like the second one, right? They are 2 different choices. They produce the same results, okay? And what's the difference? One can have better performance than the other. And optimization is about performance, right? Getting the data as soon as possible. I have some other examples here. Let's suppose that this is a representation of my original logical tree. We can apply one rule and get something like this, right? Now, when you look at execution plans and you look at the properties of the operators, you can always find logical and physical operations, right? You may have seen that when you're looking at execution plans. At this point on the optimization, everything is logical operations, right? But rules can also produce physical operations. So, and I show that one, for example, here. This is a logical tree joining 2 tables. We are supposing it's a logical operation. And there might be a rule that it shows a merge join, which is now a physical operator. Okay? So rules can find from logical to logical operations or from logical to physical operations. There's never going to be from physical to logical because it doesn't make sense. We're trying to find physical operations. Okay. On the next demo, I'm going to show how to see rules, how to see some of the transformation rules in SQL Server, and also something interesting, how to disable rules for the optimizer to use, and you can see the behavior, what happened. And I'm also going to show this optimization that we have here. We have a couple of joins, one aggregation. The traditional optimization is to do this, join the tables and do the aggregation. But sometimes doing that is a little bit better, doing the aggregation first and then joining the tables. So I'm going to show a rule that is doing that optimization. And we can see that if we disable the rule, we have the other choice. We have the other plan. So let me try that on the demo. So again, I'm going to show all of these DMBs, statements, trace flags. There is a DMB that can show all the rules available for the optimizer. So, and you have the information now on the screen. So 395 different rules that the optimizer can use, right? And obviously this changed from different versions or service pack of SQL Server. Basically, when there is a new feature that the optimizer needs to handle, it may be a new rule or an existing rule has to be changed to support the new feature. Okay, this is a query I was mentioning earlier. The traditional optimization is to do the aggregation at the end, but we can see here that we have the aggregation, right? Before they join. So it is good. I also have a script that you can use to find information about the rules that are being used for a specific optimization. So it is all this script, and you can insert your query here, so you can look at that information. Basically, the information from this view is information from all the optimizations since the time SQL Server started. Okay, so the script I have here is taking all the information before the query is running, and then the information after the optimization, and looking at the difference. Okay, so let me run that to show the optimizations, the rules used on this optimization. And we get something like this. Right, so this is the collection of rules used. And basically, we are going to be looking at this rule. You can see the name is something like group by aggregation before join. So that's the rule that's doing the optimization I was mentioning earlier. So I'm going to disable that rule using this command, dbcc rule off. Okay. So there are several commands on this session to disable rules. So those are commands that you need be careful with those, right? You are disabling rules from the optimizer. So I'm going to run that one. And basically, at this moment, the optimizer doesn't have the choice to use that rule because I just disabled that. I can clean the plan cache. And as you can see now, we have a different plan. We have the classical optimization that I was talking about, that we need to do the join first and then the aggregation at the end. So that's because I disabled this rule. What kind of physical join do we have on the plan? Merge join, right? Just for fun, I'm going to disable also, I'm going to disable this rule that is called join to sort merge join. So basically, it's going to disable merge joins. So I can run my query again. I was planning to clean the cache. So I disabled two different rules. Now I don't have access to merge joins. It is using hash join. I don't have access to, the other choice is the aggregation. We still have the aggregation at the end. Okay, so you can continue playing with these choices. There might be a moment when you disable so many rules that the optimizer is not gonna be able to do anything, right? A very simple example to do that is this. When you have an aggregation, there are only two choices in SQL Server, right? Stream, hash, aggregations. There are actually two different rules to look into those aggregations, and I show that on the screen. So that means that the optimizer is going to be looking which of both choices produce the better solution. If you don't have one, it can use the second choice. If I disable both, the optimizer is going to stop, right? And let me show you that. What kind of aggregation is doing right now? It's hash, right? So I can disable hash aggregation first. And, it is using hash. So if I disable this, it's still going to be able to do something. Where's my query? So we have a stream aggregation. Okay. How about if I disable also stream aggregation? And I try to get a new optimization. I mean, this time I'm getting an error. The query processor is not able to do anything. Call Microsoft, right? So, and that's the reason because I disabled the rules. So, okay. Let me enable all the, we also have the choice to enable DBCC rule on. So I'm going to enable all of them. It is also interesting that when you are using hints, right? When you are using hints, basically SQL Server is disabling or enabling rules to change the behavior of the query. Now, hints are documented, right? You can use those too, but they are same as dangerous, right? You also need to be really careful with using hints. Like in this case, I'm asking the optimizer to force the order of the joins and also the aggregations. Okay? If I have joins, tables, aggregation, it's going to follow exactly the way I'm writing the query. And something interesting here is the aggregation is again at the end because I'm using that hint. I'm not using any, in this case, I'm not using any trick, disabling anything, using trace flags. I'm just using a hint, and I get the same behavior. And that's documented, right? There is another trace flag that can show the transformation rules for a specific query using this syntax. So it's going to show the information only for that query. Now, something that probably I didn't mention was that when I disable the rules, like before, it's at the session level. Only that session is going to be disabled only for that session. If you open a new session, you still have access to that. But even that is a little bit dangerous. If you have a development environment, it's still a little bit dangerous because even if you do this only for your session, when you have a plan in memory, somebody else can use that plan and get confused or get a problem. So again, try to use this only on your own laptop or computer. Oh, I didn't show this one. This one has a lot of information about some other data, but you can see also the rules being used there. So, and there is one more choice to disable a rule for a specific query. You can use this undocumented hint called query rule of, and you need to specify the name of the rule you want to disable. And this is going to disable the rule only for that query. You can specify more rules using comma and specify additional rules. So if I try this one, this is the example we have seen before, right? We disable this optimization. And finally, for this demo, what's going to happen here if I disable the rules for all aggregations, stream and hash aggregations? Well, we saw that one already, right? Although we have a different error message, because now SQL Server knows that we are using a hint and is asking you to remove the hint, right? In the case before, we were not using a hint. We were disabling rules. OK. So, OK. I think we have 20 minutes or so. OK. I have two additional sections and demos. The next item is something called the memo. When we apply rules to our original logical tree, the optimizer needs a place in memory to keep all the choices, right? Because sometimes it may be looking at many different plans, dozens or hundreds of execution plans. Well, that information is kept on this structure called the memo. And there is one for each optimization. Okay? And we also have undocumented statements, trace flags, to see inside the memo. Basically, when we start the optimization, we have like this is the original logical tree. SQL Server is going to copy the operators into the memo. So that's the beginning of the memo, right? And then it's going to apply rules to have additional choices. So we may end with something like this. Our original tree was here, and we have some additional operations that we got after applying rules. So let me show you that, how we can look inside the memo structure as well. Okay, again, we have a couple of trace flags here. This is a simple case that we don't see anything on the memo because it is a trivial plan. When we have a trivial plan, we don't really have an optimization, right? It's so simple that the optimizer doesn't even bother to run the real optimization process. So a trivial plan, and there's nothing on the memo. But there are always trace flags to do different things. There is a trace flag to disable the trivial plan optimization. So I'm going to try that one. So in that case, I'm using a trace flag to disable the trivial plan. And now we have some information on the memo. Again, you're going to see a list of different operators, very similar to what we saw earlier. So you can see, let me show you this one here. So you can see the initial memo structure. I mean, there's going to be different operators on different groups, okay? And there is also a statement, a trace flag, to see the final memo structure. And this is an example of this. Okay, so that's a basic introduction about the memo and operators. So, any questions so far?
So that helped us in that memo just now. It looked like it was usefully showing the cardinality that it thought.
Oh yeah, it has a lot more information. Let me see if I can put that back. Yeah, it has, because this is the final memo structure at the end of the optimization process. So you can see additional operations and additional information on cardinality estimations and some other data. And usually you can have more groups, right? When you apply rules, basically you have more choices and more choices and more choices. So this can go really, really big. Any other question? Okay, the final topic is about optimization phases and how the optimizer is doing this optimization, right? We have a large number of rules. It doesn't mean that for every query, the optimizer is going to apply all the rules, right? It depends on the feature you have on your query. Like we show aggregations, right? So it's going to look for rules related to aggregations. If I'm joining tables, it's going to look for rules related to that. And also, it doesn't try all the complicated choices at the beginning because optimization is really expensive. So it's gonna try first to solve simple problems with applying simple rules, right? Search 0 is gonna look for OLTP queries and try to find a good solution. If there is no good solution, it's gonna do another optimization. Go to search 1, and finally, if at that moment there is not a good execution plan yet, based on a specific value, is going to try the last optimization, full optimization. Okay? We can also see that information on some DMBs and some other statements. So let me show you that on the last demo. So the basic idea is that the optimizer is going to try to solve easy problems, try to do that in a very easy way, and leave the most complicated queries to apply different rules, more sophisticated. So in this case, I'm going to show this, and there is this DMB. And it's actually the only documented feature, or almost everything I show here. So this one is something that you can run in production. It's just a DMB. And it's going to give you a lot of information about the optimizations in your system. It has really good information about the cost, if you're using, if you're having timeouts on optimization, if you're having problems with memory related to the optimization, right? If you are doing different inserts, update statements, if the optimizations contain subqueries, hints. So you can have a very good idea about the optimizations happening on your production system by looking at this. That the DMB is partially documented. For some reason, all the columns were documented before, all the counters, and later on some versions of SQL Server, it shows only like 50% of them, right? So I have my first book about the query optimizer is available for free at the Redgate website. You can get all the information about this. So we were looking at this, search 0, 1, and 2, which are the optimization phases. So this can show in your system how complicated the queries are. If your system is mostly OLTP, you will see a lot of search 0 optimizations, right? But mostly what we call OLTP, also people run more complicated queries or reports. So you may see also a combination of search 0, 1, and 2. Once again, I have a query here that you can use to show information about your about a specific query, and get and use this DMB to show information only about that particular query. Because remember, this DMB has information for all the optimizations since the time we started SQL Server. So we need to, again, get 2 snapshots of the DMB and find the difference. So basically, I'm testing a query here to get that information. And this is the information I got. It shows that the query for this optimization only went to search 0, 1, and 2. Okay. There's also a trace flag that you can use, and probably it's even better, that you can use to get information about the optimization phases for a query, right? So you get something like this. it shows information about search 0, 1, and 2. Okay? Now, remember, this trace flag only shows information about the optimization phases. The DMB I showed before has a lot other, several other information, right? So it's still really good to take a look at the DMB because it has some other good information. There's another one, another trace flag that you can use, like on this example. And it also shows information about, this is about memory, but probably we are not interested in memory, but we want to see the optimization phases. In this case, we have a transaction processing. Search 1 is also called quick plan, and the full optimization here. So you can take a look at those trace flags and take a look at the input. Okay, so basically we covered all the topics, basically 5 topics. We started talking about how the optimizer, and actually before the optimizer, how SQL Server create a tree, right? It is using the query, the syntax of the query, and it's going to create a tree. Then we talk about simplifications, how the optimizer is going to simplify that tree to make the optimization process better, faster, and even to improve the performance of the queries. Remember, we were able to remove tables or scans. Next, we talk about, at the moment, we only have a query tree, but we need to look for more solutions. And the way to do that is using rules. The rules are going to be looking for similar trees, right? They produce the same results, but the performance could be better. Okay? And we also look at the memo. When the optimizer is working with those possible plans, it's keeping all the information on the memo. And finally, we talk about optimization phases. The optimizer, it doesn't run all the rules at the same time. It's trying to fix easier problems as soon as possible. Okay, so that's basically all the information I have. Any questions at the moment?
Interested in seeing the quick plan phase of the optimization. I was tuning a query a few months ago and I got a message back saying a good enough plan has been found. Does that mean it's got to that stage as a quick plan?
So your question is about on the execution plan, good, not good, and good enough plan found?
I can't remember the exact message, but
Okay. When you look at the execution plans, there might be some information related to that, and we have 3 possible choices. And it happens that the optimizer has a specific threshold. Depending on the query, it's going to estimate how many rules it's going to apply before stopping. Because if we have a complicated query, the optimizer is not going to try to stay forever looking for choices, right? There is a point that the optimizer says, I'm going to stop, because it doesn't get much benefit to keep trying and trying and trying, and right? So when you have simple queries and you get good enough plan found, it means that the optimizer was able to find something with good cost according to that threshold, and that's a really good optimization. There is also another possible choice that you can see on that column or property of the plan. It is timeout. It means that the optimizer reached the point, the threshold I was talking about, and decided to stop. It doesn't mean that it's a bad execution plan. It may be, but it doesn't mean that. It only means that the optimizer decided, I'm going to try 200 tasks or rules. And it's looking for good choices according to a specific cost, and there is a point in time and decide to stop. So that's the timeout. The last choice is a memory problem that you can see on that property. And when you see that, it's definitely a problem that you need to take a look at. Probably you don't have enough memory, or maybe you need to simplify your query. So it's easier for the optimizer. Any other question? Okay, yep.
Recently come across a trace flag 4199, I think, which switches on query optimizer improvements and service packs. Is there any sort of
Can you,
recently come across, I think it's trace flag 4199.
4199.
Which switches on query optimizer improvements and service packs.
Mhm.
Is there any sort of
Yeah, this is documented. The question is about the trace flag 4199. So this one is totally documented. You can see on the documentation. And it is basically, when you have a hot fix or something, sometimes you don't enable the optimizations for that hotfix. Maybe you want to wait for a service pack. So if you need some of those optimizations, you can use that trace flag. So, and then the optimization is going to apply to your queries. But that's totally documented. You can take a look at that.
You can look at the SQL Server 2014 documentation on service packs.
Sorry?
You can look at the SQL Server 2014 documentation on trace plans and service packs.
Okay, any other question?
Is there a session on the new optimizer cardinality and things? In 2014, do you know?
You're asking if there are sessions on the new cardinality estimator for SQL bits? I haven't checked. I don't know. There is also a similar session about these topics by Dave. You're going to have the session tomorrow, right?
Yeah.
So if you want to try more of these topics. Okay, well, I think that's all the information I have, and thank you so much for coming to the session.